the animation. So you can see that this point rotate to this point and then translate by half, and then this point rotate to this point and then translate by half, and this point is equivalent to this point, equivalent. So this point, then I can stop lah. Whenever it go back to the original position, then it stops. I can say that this point and this point equivalent. So when I reach this point, then I can say that it go back to the original point already. Okay, how about 3, 1 and 3, 2? For 3, 1 screw axis, this is the origin position. It will rotate by 120 degree. And then 3, 1 means 3, 4 plus 1/3 of translation. Okay, translation. So 3, 4 means 120 degree. So it rotate by 120 degree and then translate by 1/3. So position 2, it will rotate by another 120 degree and then translate by another 1/3. Then for position 3, it rotate by 120 degree and then translate by 1/3. Okay, so this is 1/3, this is 1/3, this is 1/3, then this is 1 unit cell. This is 1 unit cell, so this position is equivalent to this position. All right. So how about 3, 2 screw axis? For 3, 2 screw axis, you can see that this position 1, and then you have to rotate by 120 degree position, and then we have to translate by 2/3. So this 1/3, 2/3. So we have to translate to here. So 1 translate to here. Okay. So from this position, you have to rotate by 120 degree. 120 degree and then translate another 2/3. So this is 1/3, another 2/3. So this point will translate to this point. This is 1 unit cell, 2 unit cell. And then for this point, I have to rotate by another 120 degree, right? So you will come to here, 120 degree, then come to this point. So from this point, I will translate by 1/3, 2/3, and come to this point. Okay. So I will have 1, 2, 3, and 1. So this point is equivalent to this point, right? And now I also notice that this point is equivalent to this point because this is 1 unit cell. So I have to add in this position here. And then number 2 is equivalent to this one because this is 1 unit cell. So this position is equivalent to this position. Then again, this position is equivalent to this position because this is 1 unit cell. Okay, you have studied in first chapter, right? So if any point here, after 1 unit cell, we have another point here, and these 2 points are equivalent, and these 3 points are equivalent. So this point, and this point are equivalent, right? 1, 2, 3, 1, 2, 1, 2. Redraw it. The concept of the unit cell that you study in the first chapter. This point is equivalent to this point, equivalent to this point, right? So this point equivalent to this point, equivalent to this point. All right. So you have one atom here, then you also must have one atom here, and you also must have one atom here. So if I have one atom here, then you must always have another atom at the equivalent point, this point, this point, this point. That means if I have number 2 here, then I must always have number 2 here. So that you can see here, if I draw it this way, this part is identically same with this part. This part is identically same with this part. So there'll be another one, something like this. So you can see that this unit cell is identically same with the next unit cell. This is a concept of crystal. Okay, so I only show you 2, 1, 3, 1, 3, 2. And I want you to go home to try to work on 4, 1, 4, 2, 4, 3, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5. Okay, normally there'll be 1 or 2 questions that will ask you to draw the screw axis of 4, 4, and 6, 4. Okay, either 4, I will ask you to draw 4, 1, 4, 3, 4, 2, 6, 1, 6, 2, 6, 3. There's always one question. Okay, therefore, I want you to go home and try to work on it. Okay, how to draw the screw axis for 4, 2, 4, 3, 6, 5, and so on and so on. Okay, the last one is a glide plane. Glide plane is basically the combination of translation plus mirror plane. Okay, so mirror plane plus translation. So if this is a left hand cat, then after the mirror plane become right hand cat. So right hand cat have to translate to this position. So this position will come to this position after the glide plane. This is left hand, right? After the mirror plane, it come to this position, right hand. And then it will translate by T, so come to this position, R, right hand. So this is position 1, position 2, and then again, it will, because this is not the origin position, you have to go back to origin position. So you have to you have to reflect again to this position, then become left hand, then translate to this position. Okay, so this is the basic idea of glide plane. So that's all for the symmetry. So now you can do a small test. What is the relationship between A and B if both are left hand? Two-fold rotation, right? Then how about